Hey folks, so this is the last section in chapter 10, and it's going to be talking about solving equations that are trigonometric equations. Just a first thing is let's look at our sticky note over to the right. Your very first goal is to get your trig function alone. And then just a warning, the second tip, don't divide both sides by a trig function. When you do that, you will end up losing some things. So just don't divide on both sides. So take a look here at the first example. And I've given you several different methods. First of all, though, notice the directions. We're looking for x. That's the ultimate goal, is to get x alone. We are working in radians in this one, and this particular one says no calculators. So take a look here at this junior high equation. If you had something like that, how would you solve that? Well, you would probably subtract a on both sides, and then you would subtract 1 on both sides. In other words, you're combining like terms. So let's do the exact same thing for this example 1. Let's combine like terms, but like tip number 1 on the sticky note says, let's get the trig function alone. So it's not x that I'm trying to get alone right this minute. It's secant of x that I'm trying to get alone. So the first thing I'm going to do is I'm going to subtract secant of x from both sides. When you have 2 secant x minus 1 secant x, that's just going to give you a single secant x. And then I'm also, notice I didn't write this down, but I am subtracting 1 on both sides. All right. So now we have secant is equal to 2. Secant isn't one of our memorized trig functions, but we do know that if secant is equal to 2, then cosine will equal the reciprocal. So cosine is going to equal a 1/2. So we head to the unit circle and we ask ourselves, where does cosine equal a half? And that's going to occur at 2 spots on the circle, pi over 3 and 5 pi over 3. And that gives me my 2 possible x values. Well, the second method that you could use is to solve by factoring. So you remember, once again, from earlier math classes, that if you were trying to solve the equation where you had 2 factors multiplied together to give you 0, all you have to do is set each piece equal to 0, and then solve those little miniature equations. Well, that's exactly what we have here in example 2. I have 2 factors, and they're equal to 0. So then I can take each one of those factors and set each one equal to 0. Solve for the cosecant of x. So on this one, I'm going to subtract 2 on both sides. On the second, I'll add root 2 on both sides. Again, cosecant isn't one of those trig functions that we've memorized, but I know if cosecant is equal to -2, then the sine is going to be equal to the reciprocal. Let's go ahead and keep solving on this left equation here. Where does the sine equal -1/2? We know that that's going to occur at 7 pi over 6 or 11 pi over 6. Let's go back to the right side of the equation and let's continue solving. If cosecant is equal to the square root of 2, then that means that sine is going to equal the reciprocal of that. And the reciprocal of root 2 is 1 over root 2. Rationalize the denominator and you'll get root 2 over 2. My unit circle says that this is going to occur at pi over 4 and 3 pi over 4. So this particular example number 2 has 4 solutions, and all 4 of those solutions would be legitimate solutions. They would go in the answer blank if you were taking a paper test. All right, let's jump down to example number 3, and method number 3. Use trig identities to make solving easier. Okay, so we know from earlier in the chapter, the Pythagorean identity that says that secant squared minus 1 is the same thing as tangent squared. So this makes it just slightly easier. I can take the square root of both sides. Square root of both sides, the square root of 0 is 0. One thing that a lot of students tend to forget about is that when you take the square root of both sides, you do have to consider a pos neg. But honestly, there's not any difference between a positive 0 and a negative 0, so I don't actually need those parts here because of the fact that it's 0 that we're working with. We go to the unit circle and we ask ourselves, where does tangent equal 0? Well, remember that tangent is my y value over my x value, or my sine over my cosine. And so I need my y values to be 0 while my x values are 1 or -1. Those two positions then are going to occur at x equals 0 and x equals pi. Just a side note on this one, you would not use the solution 2 pi. You would not, because of the original set of directions. So you remember that the directions said that I should be working between 0 and 2 pi, and you'll notice the 2 pi is not included. Only the 0 is included. All right, so we've got some techniques that can be used if I'm working with quadratics here, which I have been. And so the quadratic equation, ax squared plus bx plus c equals 0, there's 4 different methods that can be solved. You could use completing the square. Remember that we did that back in an earlier chapter. And you could use the quadratic formula. You could use factoring, and you could use the square root method. A lot of students say, well, Ms. Roberts, which one is your favorite? Which one do you use all the time? And honestly, there are times when one is much easier than another. So I use all 4 of them. It just kind of depends on what kind of question it is to begin with. Now, I want you to take a look at this next example, number 4 here. And when you look at this, I want you to not see the cosines. I want to take you back to Math 110 for a minute in your mind, and I would rather you see this as something like just a normal quadratic, 2a squared plus a minus 1 equals 0. What are some of my options? Well, I do love to factor, and so when I see a quadratic, I'm always going to try to factor first, and I find that this quadratic is factorable. Well, I can use the exact same method then with the cosines. All I need to do is go back, and instead of having a's in my equation, now I have the cosine of x in my equation. So then I can factor. Again, I'm using here this concept, just turning all my a's into cosines. And so now I'm right back at example number 3, where I can set each piece equal to 0. So I'm going to go one factor at a time. I'll uncover the first line here, but then I'm just going to solve on the left first, and then I'll come back and solve on the right. So if 2 cosine minus 1 is equal to 0, all you have to do is add 1 and divide by 2. Where does that happen on the unit circle? That's going to occur at pi over 3 and at 5 pi over 3. Go back on the other side when you subtract 1 on both sides. That's going to occur. Cosine will have a -1 value at pi. And so this particular equation has 3 solutions to it. All right, let's head into example number 5. Notice that my directions has changed here. It says that we should be working from 0 degrees to 360 degrees, so just keep that in mind. And then there's also a little sticky note tip over here. If factoring doesn't work, use the quadratic formula. And so take a look at this equation here in the example, and notice that on the sticky note, instead of writing it with cosines, I've written this equation as a quadratic with a's in it. So at this point, then all I really have to think about is how would I go about using the quadratic formula? And by the way, for the record, factoring will not work on this question. So if you're going to use the quadratic formula, the first thing that you have to do is you have to have 0 on one side. Okay? Hopefully you remember what the quadratic formula is. Folks, I promise you, this is something that you need to know. It's not something I'm going to provide for you on a formula sheet. Quadratic formula says, and I don't think I have it written here underneath my hidden stuff, but the quadratic formula says if you're trying to solve for x, or if you're trying to solve for x, you got x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's the quadratic formula. You can even look up some cutesy songs on YouTube about that. But this time, it's not x that I'm trying to get alone. It's literally the cosine of theta that I want to get alone first. So I have cosine of theta is equal to negative b, so that's going to be my negative 4, plus or minus the square root of b squared minus 4ac. You can see I've plugged all those in, all over 2 times a. So we clean that up, and we're going to have negative 4 plus or minus the square root of 32 all over 8. Yes, you know I'm going to want to clean up that square root of 32. Notice that I also shared my common denominator with the 2 numerators and made 2 separate fractions. And once I have 2 separate fractions, then I can reduce both of my fractions. Oh, but wait, I'm supposed to be finding theta, and all I have found so far is the cosine of theta. And so what I want to do, notice that the cosine of theta is equal to 2 different numbers. I've got that plus or minus in the middle. So cosine is equal to 2 different numbers. So let's set those, set 2 mini equations out. So we're going to have cosine of theta is equal to negative 1/2. Here's the plus version, root 2 over 2. The minus version is going to say cosine of theta equals negative 1/2 minus root 2 over 2. Now, before I do anything, I need to come up with a plan, okay? And so let me point this out to you. Notice here that cosine equals a negative number. Since both of those are negative, cosine equals a negative number. Well, if cosine is equal to a negative number, hopefully I'm going to erase the right thing here. Nope, sorry. If cosine equals a negative number, my plan is that this is going to occur either in quadrant 2 or quadrant 3. Let's take a look. Well, I'll come back to that one. Now, the next thing is that if you look at the first equation, hopefully you'll be able to tell that this is a positive number. Of course, you can put that into your calculator to see if it's positive or negative, but this is a positive number. The way I know that is that the positive fraction, square root of 2, is bigger than a 1. So it's the larger number that is the positive number. And so my plan then is that this is going to occur either in the first quadrant or the fourth quadrant. So remember, I'm looking for theta. I'm looking for an angle, and inverses find angles. So I did not write this down, but basically what I just did is I have theta is equal to the cosine inverse of this number, negative 1/2 plus root 2 over 2. And that's what I plugged into my calculator to get 78 degrees. Now, I could say that it is a positive 78 degrees and a negative 78 degrees, but unfortunately, that is not going to meet the restriction guideline. So, yes, the 78 degree part, that's okay. But then in order to get that fourth quadrant angle, what I need to do is 360 subtract that 78 degrees. So 360 subtract that 78 degrees. And you'll get 281.9529. I would strongly recommend that you put that into your calculator just to make sure that you can get those numbers. Now, for the second part of this, I kind of left you hanging on that one. We said that it was either going to be in quadrant 2 or quadrant 3. And what you find out here is that when you plug it into your calculator, when you do cosine inverse of this negative 1/2 minus root 2 over 2, you're going to get an error. And why in the world would you get an error on this one? Well, what happens if you actually find a decimal value for this number, you will get a negative number that's past negative 1. And remember, the largest cosine value on the negative side is negative 1. And so this happens to be outside of the unit circle. So that's why this would be a no solution piece. So this particular example then only had two theta values, one in quadrant 1 and one in quadrant 4, and that's all that this one has. All right, let's take a look at example number 6. This one also is not factorable. So once again, we will want to use the quadratic formula on this. And so cosine of theta is going to equal, and there's my negative b plus or minus the square root of b squared minus 4ac. All over, there's my 2a. When you clean that up, you'll get negative 2 plus or minus the square root of negative 4 all over 4. Well, there's a problem here. This is a no solution question, not like it was in the last one because it was bigger than 1 or negative 1 in that case, but because you can't have a cosine value that is imaginary. Okay, so remember that the square root of a negative is an imaginary number. Your cosine cannot be imaginary. All right, example 7. Once again, let's use this is not factorable, so let's use the quadratic formula. The first thing that I'm going to do, though, is to get 0 on one side. I'm solving for cotangent, so we'll use the quadratic formula. When I clean that up, I'm going to have 3 plus or minus the square root of 21 all over 6. Now, remember that ultimately we are going to be wanting to plug this into the calculator, but the problem is that I don't have a cotangent inverse button. And so what I'm going to do is at this point, I'm going to go ahead and turn this into a tangent that is equal to the reciprocal. Okay. Now I have two separate equations. So I'm either going to have tangent equals 6 over 3 plus root 21 or tangent equals 6 over 3 minus root 21. Now you need to come up with a plan. Let's work on the left one first. Come up with a plan. It should be pretty obvious to you that all of these values are positive, so therefore my tangent is positive, and tangent is going to be positive in quadrants 1 and 3. So at this point, and again, I didn't write this down, but basically what I'm doing here for my calculator is that x is going to equal tangent inverse of the fraction 6 over 3 plus root 21. When you plug that into your calculator, you should get 38.3541. That is a first quadrant angle, so that checks out. And then what you want to do is to get over to your third quadrant, just go ahead and add 180 to that. So add 180, and you'll get your 218 angle. So that takes care of my first mini equation. Let's also go and take care of our second mini equation. Again, if you feel like you need to plug this into the calculator to be able to tell if that's a positive number or a negative number, go right ahead. But let me just kind of share with you my thought. The top is already positive, no big deal there. And I know that the number 3 is the same thing as the square root of 9. Well, if you're looking at the square root of 9 versus the square root of 21, definitely the square root of 21 is the larger and it's negative. So you would have the positive on top divided by the negative on bottom. So you would have that tangent's negative here. And since tangent's negative, my plan is that it's going to be in quadrant 2 and quadrant 4. So once again, in my calculator, I have tangent inverse of this fraction 6 over 3 minus root 21. Plug it in, and you should, actually, you would end up getting a negative angle. You would get a negative angle here. But and I didn't write it down. I apologize. And I actually don't even have my calculator with me right this moment. But it would be a negative angle, and it's going to be a negative fourth quadrant angle. In order to get your second quadrant, go ahead and add 180 degrees to that, and that'll give you the 104 number. Please, when you get done with this question, please, please, please go back and make sure that you are typing things into the calculator and that you're getting the same thing I am. Now, you can't use that negative angle because of the fact that our restriction told us that we were working from 0 to 360. So then just go ahead and add another 180 degrees, and that'll give you your true fourth quadrant angle, not the negative fourth quadrant angle, and that'll give you 284.7760. I think that was the last question there. Of all of the examples, this one's probably the most tedious, so stick with it. Pause the video, rewind the video, watch it again, try it on your own, see if you can get it, and just make sure that you are practicing it and working through it so that you'll understand it when and if you see something like this on your test.